In this video, I want to find the partial fraction decomposition of this rational. So the first thing that I kind of look for is whether everything is factored out. And as you can tell, you can't really do anything else with this. So I'm going to start off by putting the number of terms. And if you see in the denominator, we have two terms. But however, the term itself is repeated. So the way that we write the partial fraction is x minus 7. And then after that, x minus 7 squared. So that's how you write the denominator for a repeating term. Okay, and then on the top, I'm just going to write A, and then here I'm going to write B. Okay, so the whole point of this is that I want to work with my right-hand side, and I want to combine both of these things together. So the first thing that I'm going to do is try to find the least common denominator, because if you see this one, this x minus 7 squared has two of them. This one only has one, so I got to give this one another x minus 7. So what I'm going to do, I'm going to multiply both top and bottom by x minus 7, okay? And what I'm going to get is a x minus 7 divided by, now I have two of them, so I have x minus 7 whole quantity squared. Now this one's not going to get an x minus 7. This one's going to stay by itself because now the denominator is exactly the same. So notice that this is the same as that. So this is just equal to a x minus 7 plus b divided by x minus 7 whole quantity squared. Okay, and I can just write this. So this is copying, and then here's 7x divided by x minus 7 squared. So now you see that I was able to combine this so that I can kind of equate this. So what I'm going to be looking at now, because we know that the denominators are not the same, all we're going to be looking at is now the numerator. So I'm going to look at the numerator, and I'm going to set them equal to each other. 7x equals a x minus 7 plus b. And now what I want to do, I want to find for the values of a and b. Now, what we want to look for is convenient values. And one of the convenient values is setting x equal to 7. Because when we set x equal to 7, what's going to happen is that one of the values are going to go away. So 7, oops, let me do it this way. Oh, no. What did I do? Okay. So let me put this in black. So this is going to be 7. Oh my goodness. Okay, 7. Okay, times x, which I'm going to write in a second, minus 7 plus b. And what I'm going to plug in there is going to be the 7. Okay, and what you see, this is convenient because now 7 minus 7 is going to give me 0. So this is going to give me 49 equals a times 0 plus b. This now goes away, so now b is equal to 49. Okay, so this is perfect because we figured out one of them. Okay, now usually what would happen is that the b term, in order to solve for a, the b term would have another factor, but in this case it doesn't have another factor. So what do? We can't plug in 7 again, so we have to plug in another value. What value? Does a value really matter? Not really. So, and I'll show you. So let's say I wanted to plug in another value. So let's say I wanted to plug in x equals 0. Okay. So I'm going to have 7, let me just write it in blue, 7 times 0 equals a 0 minus 7 plus b. And if you want to figure out where I'm plugging this in, this is basically what I'm working with now. I don't care about anything else. This is the equation that I'm working with. So I'm plugging in 0 into the x values. Okay, just a random number just so that I can figure out what b is. Now, we already know what b is. b is 49. Now we need to figure out what a is. So 0 equals a times negative 7 plus 49. Okay. I'm going to subtract by 49 to both sides. Negative 49 is equal to negative 7a. And then when I divide by negative 7, then I get a equals 7. Okay. So now I figured out both of them. So my full solution, okay, so the partial fraction decomposition of this rational is going to be a, which is in this case 7 over x minus 7, plus b, which in this case is 49 over x minus 7 squared. This is my answer. Okay, now let's go back a little bit here. So x equals 0. Could I have plugged in something else and still gotten the same answer? Of course. So if, let's say I wanted to plug in x equals 3, let's just say another random number, you're going to have 7 times 3 equals a, 3 minus 7 plus b, which is 49. Okay, 21 equals, this is going to give me negative 4a plus 49. Subtract the 49 over. So I get negative 28 equals negative 4a. And then when I divide by the negative 4, notice that I'm still going to get 7. So it doesn't really matter what number you want to plug in. You're always going to get the same thing. Okay, so the whole point is that you want to find the partial fraction decomposition. And the way that you do it, you want to figure out what the decomposition will be, okay, from the very beginning. Find the least common denominator between the two, combine them, only look at the numerator, and then you want to plug in values that are convenient to you, okay? And if they're easy, then cool, we can plug in easy numbers. If they're not, like this one, then you can plug in a random number, okay? And that should be it.